Hi, hello, welcome back to Chemical Kinetics, Class 3 Collision Theory. Collision theory is one very important part. According to collision theory, if a reaction is to be done, if a reaction is to be carried out, then collisions are mandatory. Okay, now collisions between the molecules are mandatory. What do you mean by collisions? Okay, now for example, a molecule is here, another molecule is here. These two molecules must collide with each other. Okay, now, and those collisions must be perfect collisions also. So the number of binary collisions per unit time is given by this formula. Okay, now z is equals to pi sigma square ab under root of 8 kt by pi mu n a n b. Actually, and here this sigma indicates collision diameter and mu is reduced mass. Not much important. You can just see and leave this. Don't worry, I didn't see any question based on this. It is there in notes, so you're just going with this. Don't worry about this much, but just see the formula. All collisions between the reactant gas molecules do not lead to product formation. Okay, now don't think that each and every collision is going to give you the products. Only few collisions, and those collisions are called fruitful collisions, or you can say effective collisions. Not each collision gives you the exact what you say products. For example, same example, because I love cricket, I play cricket. Cricket is the only game which I know, that's why. For example, a batsman, like opening batsman, pinch hitter, for example, let us say Pant type batsman, otherwise Kohli type batsman, Rohit Sharma type of batsman. If he is coming, Hardik Pandya, right? Okay, if he is coming from first ball onwards, he will be trying to hit a sixer. Okay, now because six, all sixes he wants to make, because if he is playing a T20 match, if he is going to play all sixes, okay, now both batsmen, if all sixes, then you can expect a maximum score. But is it possible? Out of 120 balls, there may be 12 sixes or 15 sixes, or at the most 30 40 sixes in a match. Okay, now that's what I'm saying. So all 120 they are trying to hit, but it is not possible. Even you can try in nets also. Okay, now you cannot make all ball sixes, but you will definitely try like that. Only few number of collisions only converted into effective collisions, like your sixes, right? The minimum energy with the molecules which they should possess, okay, now to get convert into the products is called threshold energy. In the last class I was giving you the graph. Okay, now if it is an exothermic reaction, it will be like this. This is the energy of the reactants, this is the energy of the products energy is less, means it is exothermic reaction, energy will be released. And here when energy is less, you can see this part, this is called activation energy, and this is threshold energy. This is he's saying about this one. So the minimum extra energy which the molecule should possess over and above the average energy to enable them to react is called energy of activation. This is okay. So this much of energy they should get. Okay, now they must cross this stage. They must start cross this threshold energy level. Okay, and threshold energy if they cross, they will be converted into products. Direct going off like this is prohibited. It is not possible. They have to cross through the threshold energy state only. Okay. So activation energy is equals to threshold energy and energy of reactants. This is one simple basic formula. So the energy of activation differs from one reaction to other. For all the reactions, it is not same. For example, let us say this is one reaction. It is like this. For other reaction, this may be like this. So in the second reaction, activation energy is more. For the first reaction, activation energy is less. It depends. It depends. The greater the energy of activation, then reaction will be generally slow. You can see in this case only here less activation energy is there, so they can get easily. Here more activation energy is there, molecules may not get this much of energy, so these reactions will be slow and these reactions will be fast. Lesser the threshold energy, lesser the activation energy, the reactions will be fast. So this is that point. The lesser the energy of activation of a reaction, the higher will be the rate constant, also the rate of reaction. Okay, now rate constant higher means rate of reaction is also higher, because rate is equal to rate constant into concentration. So when K is more, obviously rate is also more. Molecules possessing the threshold energy are called activated molecules. Okay, now when they are getting the particular energy, they are called activated molecules. Collisions between activated molecules only lead to the chemical reaction. This is what we were saying till last time. So not all the molecules, only few molecules will be having that particular energy, and those particular molecules collisions are only called, what you say, perfect collisions or fruitful collisions. Okay. When activated molecules collide with an activated another complex, or a transition state is formed which changes into products. This is again the same thing. This they are saying. This is called a transition state. Transition state is mandatory so that they can be converted into products. Without changing into transition state, the direct conversion is not possible. It is not there. They need to go to the transition stage. The energy of the activated complex is greater than the energy of the reactant and also the energy of the products, obviously. Okay, this is energy of the reactant, this is energy of the products, this is exothermic change. Okay, this is threshold energy, or you can say this is endothermic change, reactants energy, products energy, but threshold energy is definitely greater than both of those. That point is mentioned in this 23rd point. The fraction of molecules which possess the energy of activation or more than the energy of activation is given by the Boltzmann factor. That Boltzmann factor is E is equals to minus EA by RT, this particular term. With an increase in concentration, the number of activated molecules definitely increases. When you are increasing the concentration, the possibility of activated molecules will definitely increases. So number of effective collisions also increases. When number of effective collisions increases, rate also increases. So rate is directly proportional to concentration, except zero order, except zero order, except zero order. For all the remaining, rate is directly proportional to concentration. That point is mentioned here. Okay, so we'll take a break here. We'll continue in next class, class 4. So in this we were discussing only about the activated states, activated molecules. Okay, now how to get the activation molecules? By increasing the concentration, by increasing the temperature, whatever it is. If they are getting that energy, they will be converted into products. Higher the activation, lower is the speed, lower the rate, less possibilities. Lesser the activation, more speed, more possibilities, right? Thank you. Don't forget to join class 4.